Hi, my name is Max Beal, and I'm a student at Northern College in Ashland, Wisconsin. And today I will be presenting a research in progress poster on our assessment of water table drawdown as a productivity indicator in two forest systems in Ashland, Wisconsin. So, a little bit about our background. Rates of vegetative productivity are, of course, very important in understanding local climates, water cycles, and ecosystems. But tracking that productivity is usually done through respiration. And if you're using something like eddy covariance, which is very accurate, you are going to need a lot of infrastructure for that tool. It's going to be pretty expensive, and you need certain conditions. So our thought was maybe we can take something that's a little easier to measure and that we can measure on a very fine time scale, similar to eddy covariance, and see if there are any relationships between in this case, water table drawdown, and other productivity indicators that we can get on a larger time scale from satellite products, such as leaf area index, evapotranspiration, and weather type. And the idea being here that maybe we can still look at productivity on a small time scale if relationships do happen to occur between water table drawdown and these other indicators. So a little bit about our methods. We drilled 2 wells for 2 sites, one in a cedar forest and one in a black ash forest in Ashland, Wisconsin. And we put hobo water level loggers in each of those wells, and they returned water table data every 15 minutes, and we did this from 2014 to 2018. I'll explain this map here because it's a little difficult to see. There's a very small blue dot on the map. That is our cedar study site, and the very small orange dot, if you can see it, is our black ash study site. And these red lines here are a 2-foot contour interval. And so this kind of leads into why we chose these sites, and that's because there's a very thick layer of clay and organic soil here, and a very low elevation gradient, which does not allow water to infiltrate, and it does not allow water to run off very easily. And so that makes sure that water is leaving our system through transpiration or evaporation. And so what we did was we took these water table data and we synthesized them into daily water table drawdowns. So water table at the start of the day, the end of the day, difference between the two. And then we removed precipitation so we wouldn't have weirdly large increases in water table. So what we found when we compared our drawdown to these indicators is that there was a significant positive correlation between leaf area index and daily drawdown, as well as evapotranspiration and daily drawdown, but only at our cedar study site. And as you can see here, our cedar study site graphs are on the left-hand side of the results panel. And so you can see as leaf area index measured in meters of foliage per meter squared of the ground increases, we can also see a greater increase in the daily drawdown, and that's measured in meters. And similarly for the evapotranspiration, we can see as that increases, and that's measured in kilograms per meter squared of ground, we also see drawdown increasing as evapotranspiration increases. And we do not see this at the black ash study site, and I'll get into why we think that might be in a moment. As for our final analysis, the weather type analysis, what we did was we compared average daily water table drawdowns between overcast days and sunny days. And we did not find that these were statistically significantly different on overcast versus sunny days for either site. But as you can see, it sort of follows the same trend that we saw with the leaf area index and evapotranspiration, where there appears to be no trend at all for the black ash site. But the cedar site on the left here appears to have maybe a slightly higher average daily drawdown on sunny days. Again, not statistically significant, but certainly a trend that we would like to look into in the future. So what does this all tell us? Well, our initial results indicate that leaf area index and evapotranspiration have a significant and positive correlation with our daily drawdown at our cedar study site. And so this gives us hope that in future studies, if we increase our sample size and get a greater diversity of sites, that we eventually might be able to start predicting some of these productivity indicators from water table drawdown. But before we do that, one of the things we want to figure out too is why we saw this lack of relationship at the black ash study site. This may be due to site characteristics. The water table is often above ground at the black ash study site, creating kind of a swampy environment, and that may have impacted the ability of our water level loggers to read, and maybe even the ability of the trees there to transpire. Or it might just be a difference in the species between our sort of larger cedar trees and these little very densely packed black ash trees. And so that's something we would like to investigate in the future as well by getting a larger diversity sites at a greater spatial scale. And again, we want to keep investigating our trends in water table drawdown relative to weather type, because while we didn't find anything statistically significant in this analysis, we think that maybe with a greater, study area and a greater sample size, the data might be worth analyzing again. So in conclusion, future studies will need to incorporate a larger number of sites in a greater diversity of areas, and we would just like to keep on collecting more data and see where this goes. So thank you so much for watching. I really appreciate it.